Okay, so following on from our video about volume, we want to have a look at surface area. I actually think surface area is harder than volume. There are more pieces to consider, more parts to the calculation, and it's very easy to just miss off one surface by not being systematic and careful about how you go about doing it. But essentially, in terms of what you need to do, it's not overly difficult. You're just calculating the areas of all the different shapes that make up the surfaces and adding them together to calculate the total surface area. But it is just very, as I said, very easy to just miss off one shape or not think carefully enough about the solid. Something as simple as a rectangular prism, I find students often misread what's happening and they think, oh, well, there's 4 sides that are 10 by 7 or 10 by 4, when actually there's only 2 of each. So we've essentially got, what you need to think about is how many unique surfaces do I have? So in this case we have 3 unique surfaces. There is one on the bottom here, which is a 10 by 7 rectangle. There is another one, which is over here, and that is a 7 by 4 rectangle. And then there is a final one on the back here, which is a 10 by 4 rectangle. Okay, so you've got 3 different surfaces and there's 2 of each of those surfaces. So the surface area here, there are going to be 2 rectangles that are 10 by 7, so that's the purple ones. Okay, and then there are also 2 rectangles that are 4 by 7, that's the orange ones. Okay, it's here and there. Okay, and then there are 2 rectangles, the back and the front, which are 4 by 10, and that's the yellow one. Okay, so being really careful about, you should have 6 surfaces, 3 unique, and 2 of each of those unique surfaces. So 2 times 10 is 20, times 7 will be 140, plus 2 times, or you could do 4 times 7 is 28, and double that is 56, plus 4 tens are 40, and double that is 80. Okay. So again, use your CAS at any point, wherever you need it, use it to supplement and help as needed. So 140 plus 80 plus 56 is 276, and our units here, so the length units are in centimetres, the area units therefore will be in centimetres squared. Okay, part B, we have a triangular prism. So again, let's try and break down and think about what are the unique surfaces we've got. So obviously we've got the triangle, okay, that's one surface, and there are 2 of those. Alright. Now, then we've got a rectangle at the back here, okay? So obviously it goes down into there behind that purple triangle. So we've got that shape there, and that's going to be 4 by 12, okay? And then we've also got one on the bottom, a rectangle on the bottom here, and that's going to be 6 by 12. But then we also have, on top of all of that, the sloping rectangle. And that is going to be whatever this length is, which we don't know, and by 12. Okay, so it's really important. It's really easy to miss a surface here, and we're going to need to think about this purple triangle on the end. It's a right angle triangle, and using Pythagoras to find this length here. Okay, so if we call that x, we know that x squared is the hypotenuse, and that therefore is equal to 6 squared plus 4 squared. So that is 36 plus 16, which is 52. And so x is the square root of 52, which is approximately, square root of 52, which is approximately 7.2. Okay, so now we can think about our surface area. We're going to have 2 triangles, and the area of a triangle is half times base times height. Okay, so that's our 2 triangles, okay, plus we're going to have the yellow rectangle at the back, which is 4 by 12, okay, plus we have the orange rectangle on the bottom, which is 12 by 6. Alright, we just move that along, we're running out of room. And then finally we have the blue rectangle on the front, which is 12 by this number we've just worked out, 7.2, or root 52 if you want to be exact. Okay, so let's work all this out. The 2 and the half are cancelling each other out, so that's essentially 24 plus 4 12s are 48, plus 12 sixes are 72, plus, and then we're going to have 12 times this value we've just worked out up here, which is 86.5. Okay. Alright, so it is approximately, so we're going to do 24 plus 48 plus, and again you can put the whole thing into your calc at the start if you need. Sorry, that's plus 72, and then plus this decimal value we've worked out. So the surface area there, sorry, I accidentally multiplied it that last step. Should have been plus. Again, that sort of does my answer make sense. I was automatically thought, oh, these four numbers are all less than 100. They shouldn't be adding up to more than 400. So something wrong with what I'd entered in there. Okay, so total surface area, what was our rounding here? 1 decimal place. So 230.5, and the units will be meters squared. Okay, part C, we have a pyramid, and again it's just about thinking about all the different surfaces. What do we have, etc. So the base is a square, okay? So the base is a square, so that's really easy, that's 6 by 6, okay? Then we have triangle, where that is 6, okay, but we don't know what the height of that triangle is. We're going to need to know that distance there. Let me make that a different colour so you can see what I'm referring to. We need to know that straight up the middle. Now the good thing to know is that the 4 triangles are all the same. It's 6, they all have a 6 centimetre base, and this green height I've just highlighted there is going to be the same for all of them. So we need to find that green height. Okay, and to do that we're going to form a right angled triangle. Okay, using the height of the pyramid. So this vertical height here, that's 5. And this horizontal distance here is going to be half of the side length, so that's going to be 3, because I've just gone to the middle. So essentially, I'm just pulling out that green triangle, where that's 3 and that's 5, and I need to find this slant height, okay, so which will be the height of the red triangle. So we're focused on this right angled triangle here. We'll use Pythagoras to find the height, or the, in this case, it's the hypotenuse of the green triangle. It is the height of the red triangle. So h squared equals 3 squared plus 5 squared. So that's 9 plus 25, which is 34. And so h is the square root of 34, which is approximately 5.8. Okay, so now if we think about our surface area, we've got the square on the bottom, okay, the 6 by 6 square on the bottom, we've just got one of those, plus we have 4 triangles, the red triangles. Okay, so this was that's the purple square on the bottom, and these are the red triangles here, okay. And the base of those red triangles is 6, and the height of those red triangles we've just worked out is this, approximately 5.8. Okay, so our surface area is going to be 6 by 6 for the square on the bottom, plus we're going to have 4 triangles. Area of a triangle is half, times, in this case, the base is 6, and times the height, in this case, is that rounded decimal we've just worked out, 5.8. Alright, so that's 36 plus 4 times a half is 2. 2 times 6 is 12, so it's going to be 12 times 5.8. Alright, so we've got 36 plus 12 times this number we worked out up here. And so that is 105 point, now to 1 decimal place. Oh, again, we've had this come up frequently. So it's 0.97, rounding to 1 decimal place, that 9 will need to round up. So it is going to be 106.0 to 1 decimal place, centimetres squared for surface area. Okay, surface area of a cylinder. So we need to think about the surfaces of a cylinder. We've obviously got the 2 circles on either end. Okay, so this circle at the top here, and then a circle down the bottom here, easy, okay? But then we also have the curved surface, okay? So this whole curved surface here, which if you think about unfurling that, if you think about sort of taking the wrapper off a tin can, for example, it would be a rectangle, all right? And so it's a rectangle where the circumference of the circle corresponds to the width of the rectangle, okay? So that's going to be the circumference of the circle. Okay, and the height of the rectangle corresponds to the height of the cylinder. Okay, so circumference of the circle, if the cylinder has a height of h and a radius of r, then area of this is pi r squared, area of this is pi r squared. The circumference of the circle is 2 pi r, and so therefore the area of this is 2 pi r, which is that red length, times by the height. Okay, and so the surface area of the cylinder is our two circles, 2 lots of pi r squared, plus the rectangle, 2 pi rh. It is really important that you understand, whilst, in further maths you get all the formulas, this formula will be on the formula sheet, etc., etc. It's important that you understand what those parts of the formula comprise, because you might get a problem, for example, where it is an open can. Okay, so there's no lid, in which case you need to know that you only need one of the circles. Or it might just be a cardboard, like a toilet roll with no ends at all, in which case you need to know that that's the bit that you're after. So it's really important that you're able to understand what the bits of the formula represent. Okay, example 2, find the surface area of each of the following solids. If it hasn't told us that it's an open cylinder or, doesn't have ends or whatever, then we'll assume it's got 2 circles on either end and the curved surface. Alright, so surface area of a cylinder, we need the height of the cylinder and we need the radius of the cylinder. So radius is 6 and the height is clearly 10. Oops. The height is 10. Alright, so it's going to be surface area is 2 pi r squared, because we've got 2 circles, so 2 pi times 6 squared, plus 2 pi times the radius, which is 6, and times the height, which is 10. Okay, 6 squared is 36, times 2 is 72, so that's 72 pi, plus 6 tens are 60, times 2 is, that's 120 pi, and so adding together 72 pi with 120 lots of pi is 192 lots of pi, which as a decimal, 192 times pi. Control Enter, because you want, again, one decimal place. Won't always be one decimal place, make sure you read the question. 603 point to one decimal place, that will be 2. And we're looking at surface area, so the unit is centimetres squared. As I said, you don't need to do this step yourself. For me, that's quicker and easier than typing the whole thing into your CAS. Just type the whole thing into the CAS at the beginning. 2 times pi times 6 squared plus 2 times pi times 6 times 10. Control Enter. We get straight away to the same answer. Okay, part B, surface area of this solid. So again, we assume all of the surfaces are solid, that it's not open unless it tells us explicitly. So we've actually got here a couple of different things. So we've got 2 semicircles. Okay, so essentially we've actually got one whole circle in terms of surfaces. Alright, so we've got 2 semicircles, so we've got a whole circle, plus we then have, let me unhighlight those so you can see what I'm talking about. We then have the curved surface. Okay, so all of this, okay? So that's half of the curved surface, so it's going to be half of this. So again, it's important that we understand how to use the formula. So it's going to be half of that curved surface, and then in addition to that, which is where we're likely to miss it, we also have a rectangle on the top, okay, which would be 6 by 9. Alright, so let's think about our surface area. We're going to have the 2 semicircles, which together make a whole circle, okay, that I highlighted in purple earlier. We are going to have the curved surface of the cylinder. Okay, so we've got, it's not the best, let me go with the angle a bit better. Okay, so we've essentially got the curved surface of the cylinder, which is half of the whole curved surface, and then in addition to that we also have the rectangle on the top. Okay, so the rectangle is 6 by 9. The curved surface, we need the height, which is that distance, so that's 9, and the radius is going to be 3 in this instance, and for this circle we need the radius of 3. Okay, so we've got the whole circle, which is pi r squared for the area, so it's pi times 3 squared, plus we're going to have half of the curved surface, half of the 2 pi RH. Okay, so half times 2 pi times 3 times 9 plus the rectangle, 9 times 6. Alright, so this is 9 pi, the circle, plus here we've got 2 times a half, that's just 1. So we've just got pi times 3 times 9, 3 times 9 is 27, so it's 27 pi, plus 9 times 6 is 54. 9 pi plus 27 pi, so it's 36 pi plus 54, so that is the exact surface area. So 36 times pi plus 54, Control Enter, is 167 point, to one decimal place, is 1 centimetres squared for the surface area. Okay, surface area of a sphere, again I'm just going to give the formula here. So surface area of a sphere is 4 pi r squared, so the volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. So we want to find the surface area of each of the following solids. Okay, so we've just got a straight sphere here with a radius of 8, and so therefore the surface area is 4 times pi times 8 squared. 8 squared is 64, 64 times 4 times pi exactly is 256 pi, and to one decimal place is, Control Enter, 804.2. We don't have any units there. It is square units. Okay, surface area of here we have a hemisphere on top of a cylinder. So obviously if we were to just look at a hemisphere, the hemisphere has the curved surface, but it also has the circle on the bottom. But because it's joined onto the cone, that's not an outside surface of this shape. Okay, so we essentially have the hemisphere. Okay, so it's just going to be the curved surface of that, plus we have the curved surface of the cylinder, and plus we've got the circle on the bottom. Okay, so just the curved surface there, and then just the circle on the bottom there. Okay. Alright, so our half of a surface area of a sphere, so the whole surface area of a sphere is 4 pi r squared, so we're going to have half of that, which essentially is 2 pi r squared. So half times 4 times pi times, now the radius is 5 squared, plus we have the curved surface of a cylinder, which is 2 pi RH, so 2 pi times the radius is 5, and the height of the cylinder is 12. Okay, and then we have the circle on the bottom, which is pi times the radius squared, so pi times 5 squared. We've just got one circle. So again, it's just about identifying what are the surfaces of this shape, how many are there, and what formulas do I need for those. Okay, half times 4 is 2, as I said, it's 2 times pi times 25, so that's 50 pi, plus 2 5s are 10, times 12 is 120, so that's 120 pi, plus this is 25 pi. Okay, so it's 75, so it's 195 pi, exactly, and as a decimal, that is 612 to one decimal place, 0.6 centimetres squared for the surface area. Okay, work today is some questions from exercise 17F and then some additional practice from the worksheet in Appendix C.